So for letter A, let's solve and determine the maximum flexural stress at 2 meters from the left support. So there are actually two ways in solving in getting the moment at 2 meters from the left support. One is by graphical. So if we try to look at here, this is the location of the left support. And if we try to draw a line padung sa right side, 2 meters, makita na nato ang location sa ato ang gipangita nga moment. For example, here, diri na ko siya maibutang. This is just an estimated portion. And by drawing a line vertically, this represents the moment at 2 meters. Okay, again, the distance here, kaya ako na siyang gi-mention ganina, 2 meters na siya. No? So, ganun dili day ko pa dong sa left because this is 1 meter only. No? So, and it's impractical to measure 2 meters to the left side nga wala na kay ma-measure. No? So, and also, ngayon diri ra siya kutob because this broken line here represents 2.6 meters from this point, diba? Kaya na-measure na nato pud ganina. That's actually the x value. Okay, so if that's the case, then we need to find this portion of the moment. How do we solve that? Actually, we need the spandrel. So, the spandrel that we are gonna draw is from this portion of 86.4 horizontally because this represents the 86.4 and the distance vertical padung dira for this represents the height of our spandrel, and of course this is the curve of our spandrel, no? So ato lang siya i-redraw. Itong i-redraw dire, this is the 2.6 that we are talking about. So this is 2.6. Ako lang siyang i-measure. This is 2.6. Then of course, nadiri ang ato ang height. What is this height equal to? This height is basically the difference, I mean the amount nga atong gi-subtract from the negative 15, no? And then this is the spandrel. Okay. Alright, so where's the location of our zero moment line? Remember, this is the location of the zero moment line. No? Diba? Sakto? Ang pag-illustrate na to. The same? Yes, the same. And then, kay bao na ta ani nga distance, I mean nga height, that this height is actually just the height nga 86.4. And then this height here is also 15. Okay, if you try to add 15 and 86.4, it's the amount that you subtracted nga 101.4. No? Okay. Okay. Of course, this is the tip of the spandrel man. And according sa tip of the spandrel, sa diri sa babaw, it's 86.4. No? So I hope wala mo nasaag ana nga portion. And then here's the moment. Here, ako lang i-draw ang moment na to. We need this moment, M2. Diba? So how do we solve M2? We need this distance or height. Diba? 86.4 para ma-obtain na siyang M2. So ato sang iswat si M2. And also another height. Here. Another height. Kani siya. This represents, I'll just call this one as our value y. No? Para M2 di ay, M2, it's just 86.4 minus y. Diba? Sakto? If you try to add M2 and M2 and y, it's 86.4. Sakto. Alright, so with that, diba mag-ratio and proportion man ta? And remember, ningon na ta ganina that This distance here is 2 meters, no? 2 meters. So therefore, ang nahabilin dere, it's really important to get this 0.6 for it's going to be used as our ratio and proportion, no? Kung makita ninyo ang figure, if makita lang jud, so mo ni atong ma-compare. This big spandrel, tarong lang natin draw. This big spandrel and this smaller spandrel. No? So this is 2.6. Yeah, this is kani ang duha, that's 101.4, and this one here is our 0.6, and this is our y. So by ratio and proportion, we can have 0.6, ano, pwede ra kan 0.6, but ato lang i-follow ang sa katong formula nga akong gi-give. Y over 0.6 square equal to 101.4 over 2.6. So our 2.6 square. By the way, nganong square na siya? Because the degree of curve here is 2 degrees, diba? No, makita ninyo, no? Yeah, it's 2 degrees. So mo nang naka-square siya. So y is, how much is y? It's 101.4 times 0.6 square divided by 2.6 square. The value is 5.4. So it's 5.4 kilonewtons meter. Yeah, mo na itong i-substitute sa y nga value diha. Okay, so we can now solve for M2. M2 is equal to 86.4 minus 5.4, and the value M2 is 181, no? Minus 5.4, the value is 81 kilonewtons meter, no? So this is the moment that we will be getting, or that we will be using. Sakto ba? Sakto, no? So the second way in solving M2, it's basically just cutting the beam. Diba, remember, this is 2 meters man diri dapita. So all we have to do is project a line padung dito sa ato ang beam. So ato lang idagan ang beam, ang line dito padung diha. So vertically, this is the 2 meters location, no? So nani siya dira nga portion. So all we have to do there is ato lang sa siyang ibutang. So diri man to, no, ang projection. So all we have to do is cut that portion. So i-cut na nako siya and consider the left segment, no? Kay man ka nga at that point of cutting, that's 2 meters. So in a cut, we can actually redraw the figure. Okay, so let's redraw the figure. We're expecting a value nga 81, ha? So actually ato lang siyang i-redraw, and this is the distribution, and this is the point of cutting. And do not forget na akay R1 diri nga 108. Then this is 1 meter, and then this is the distribution. Pagkahuman, this is 2 meters, and since nagcut man ka diri nga portion, then you will obtain there a moment and shear, no? We're after of the value of that moment because that moment represents M2. Okay, so how do we solve for M2? What we're gonna do is assume always assume a positive bending. This is how to create a positive bending. No? Nga positive bending na siya because if we try to rotate this counterclockwise, the fiber of the beam becomes like this. I-broken lang nako. From horizontal niya, ipa-bend pa dong babaw, ipadong clockwise man. So, it's something like that. So, if that's the concave upward, then concave upward represents positive moment, no? So, mo nang inanaw na to siya pag butang. So, there. That's how to create positive moment. And let's solve for M2. All we have to do first is get the resultant. So the intensity here is 30. So it's 30 times 3, that's 90 kilonewtons. And right now, we're now ready to solve for M2. How do we solve for M2? Use the summation of moment. Summation of moment at point of cutting M2 equal to 0, clockwise positive, counterclockwise negative. Okay, so there, M2 is negative. Okay, counterclockwise man siya. And then 101 rotate at point M2, so that's positive. So 108 rather times moment arm of 2 meters, then minus 90 times the location. The total distribution is 3 meters, therefore this is 1.5. So that's 1.5 equal to 0. So we're going to transpose this M2 to the other side para mahimong positive. So positive na siya. 108 times 2. So 108 times 2 is 216. Minus 90 times 1.5. It's 135. Then M2 here, we're expecting an 81 value sa M2. 216 minus 135. So that's 81 kilonewtons meter. So as you can see, we still got the same value from the two different ways. So which one do you think is easier and simpler? Anyway, it's all up to you. So basically our M2 is 81. So we're preparing that because we will be using, we will be solving naman a flexure is my over I. Diba remember, y ang gamiton whenever na-specify kung asa sa fiber niya. The fiber, kung 20 millimeters from the top or something like that. But it wasn't said in the problem. And actually, the problem says maximum. Pasabot, we're getting the C value. No? Katong MC over I. So instead of y, I'll be placing C. No? So, asa din nako siya gikuha. So, remember that our section is a rectangle. Ingon ang problem. Ningon ang problem nga rectangle siya. No? So, iyang base sa problem kay it's 300 and 600 iyang height. So, the base is 300, then iyang height is 600. So the location of the neutral axis is of a rectangle is actually at the middle. No? Pasensya kayo nga wala siya sa middle. Cut and paste. Ito siyang ibalhin. I guess mo na siya ang middle. Okay. So we're getting the moment M2. We have this distance. This distance here is C1. Yeah, this distance here is C2. Yeah, since this is rectangle man, therefore C1 is just equal to C2. And C1 is 1/2 of 600. This is 300. So 1/2 of 600. And that is 300. Okay. So mo na ang ato ang C. Then ang atong M of course is our M2. And next, let's solve for I. I of a rectangle is BH cube over 12. If you do not remember this, joke. Scan, nasa yung statics. So base is 300. The height is 600. No, we're actually basing the rectangle, huh? So divided by 12. And then our moment of inertia, I, is 300 times 600 cubed over 12. It's 5.4. 5.4 times 10 to the 9th mm to the 4th power. Since na namatay ina nga mga values, we are now ready to solve for flexure. And our moment here, forget, pila values at the moment, it's 81. 81 kilonewtons meter. Then our C is 300. It's 1/2 of 600. Then divided by unit de this is millimeters. And then I is 5.4 times 10 to the 9th power mm to the 4th. And of course, since our kilonewtons and meter aren't in its simplest form, so atong gi-expect aning answer is in megapascal, so it should be in newtons per square millimeters. So atong i-convert. So we're having 1,000 millimeters over 1 meter para ma-cancel out ning 1 meter dira. And also, you will have another 1,000 newtons for 1 kilonewton. So para ma-cancel out ng kilonewtons. And this is your flexure at 2 meters. Basically, that's 81 times 300 times 1,000 and another 1,000 all over 5.4 exponent or times 10 to the 9. The answer is 4.5 newtons per square millimeter, or this is in megapascal. Okay, so this is at 2 meters from the left support.